want to get the first element in the list, how do you do that? We do that using what we call indexing. So if I want to get apple, you know, when I print fruit here, if I print fruits, I get the entire list: apple, orange, tomato, and banana. What if I want to only print apple? You come here and say fruits, okay, fruits, and then you put 0. This is what we call indexing in Python. You are asking Python to only print the first element in the list. If I want to print the second element, what will I do? 1, isn't it? I put 1 here. If I want to get the second, or the third rather, okay? So you keep on doing that. If it's a lengthy list and you want to start printing from the extreme, you can use -1. Okay? You can have -1 here, and when you run this, you have banana. Okay? If you have -2, you have tomato. If you have -3, you have orange, like that. What if you attempt to index an element that's out of range? Let's say you want to index 5 here. You know, this is 0, this is 0, this is 1, this is 2, and this is 3. And here you're attempting to index 5. What would be the output of this thing? It will give error, isn't it? Because it's out of range, isn't it? This is out of range. It's a list index out of what? Out of range. One good thing about list is that it can contain heterogeneous elements, isn't it? Yeah? Okay, I've shown you this earlier. Here we declared a list containing 4 elements: apple, orange, tomato, and banana. And then here we're printing the type of variable. Remember, the type function is used to print out the type of variable, isn't it? If it is a string, it prints out str. If it's an integer, it prints out what? Int. And if it is a list, it prints out list. So if you do this, it prints out list. And then if you print out the entire fruit, it prints out the entire element, isn't it? Now if you do fruit 3 will print out what? 1, 0, 1, 2, 3. That's banana, isn't it? Yeah? But if you attempt to index 4, it says list out of what? It says list out of range. So for example, you can one good thing about lists is that they are mutable. They can be changed. Remember, in our initial list, the list contains apple, orange, tomato, and banana. And when you submit this list to whoever, he now argues that the third element, tomato, is not a fruit. And then you are forced to change it to another alternative fruit, isn't it? So you can just come here and say fruit 2 is equal to what? Apricot. So you can come here and say, you know, this apple, orange, banana. You can come and say fruits. Let's say 2 plus apple is equals to, give me another fruit. Let's say mango. And then when you run this and you print out fruits, you see that the third element is no longer tomato, but what? But mango, isn't it? So furthermore, we can modify lists in various ways. You know, we've seen several list methods, string methods yesterday. Lists also have their own methods. basically functions that can be applied only on lists. And how do I get a comprehensive list of all the methods that can be applied to lists? I can do there, isn't it? Just like I did yesterday for what? For strings. If I want to print all the list methods, I do what? I do str, isn't it? It prints everything. So all of these guys are applicable to what? To strings. So I can also come and do same on lists. Come here and see a list, and I run this, and you see all of these are applicable to list. Some of them are intuitive, isn't it? For example, append. What does append do? To add something to the end of something, isn't it? For example, what's fruit? What's fruit? Apple, orange, mango, banana. Give me one more fruit. Let's see. My friend likes fruit. He's giving me variety. Since he gave me mango, he's now saying. So I can say fruits dot append. What do I want to append? You said pineapple, isn't it? Isn't it? If you run this and you now print fruits, you see that it's now apple, orange, mango, banana, and what? And what? And pineapple. So we have successfully appended a fifth element to our list, which was hitherto having 4 elements. So and that's how you apply all the others. If you clear, what happens? If you say fruits dot clear and you run this and you print fruits now, what happens? You see that fruits is now an empty list. So clear is a function that clears the entire content of a what? Of a list. Okay? What again? Copy just copies the content. Count, it counts the number of elements in a list, isn't it? For example, let me come here and see. Let me create a list of let me see numbers, isn't it? Give me some numbers. 1, 2, 3, 6, 4, 5, 3, 5, 7, 5, 5, 2, 5, 5, 5. Well, first of all, if I want to print the first element, we all know that we index using what? We start indexing from 0, isn't it? That will give me 1, isn't it? If I want to get the how many elements are there in this variable, so you can do that programmatically using what? The len function, len. And if you do numbers, it tells you that there are what? There are 14. If I want to count the number of 5s in this list, I do what? No, I do numbers dot what? Count. What do I want to count? The 5s here. And it tells me that there are what? There are 6 5s in this particular list. It tells me that there are 6 5s in the what? In the list. So what again? Extend. Yeah. Extend and append are related. Only that the way in which you use them is different, isn't it? In append, you simply add another element to the end of the list. while extend enables you to merge two lists together, isn't it? For example, you have for example, in this guy, that these numbers, if I say numbers dot append, let's say 180, 189. If I call numbers now, what happens? It will add 189 here, isn't it? What if I come here? Let me create another list here. Let me say I have a list x equals to Yusuf, Sani, Asabi. And I come here, I run this, and then I say, please, I want to extend these numbers dot extend with what? With x. So what happens? You know, numbers is a list. X is also another list. So when you extend numbers with x, the entire content of x will not be what? Will not be added to what? The numbers. And if you call numbers now, what happens? You have what? You have the entire list together with what? With the content of the x variable. How would this differ when I do numbers? Okay, let me run numbers again. Let me run these numbers again. Okay. So if I append 189, so my numbers will not be what? Will not be this, but what will happen now if I come and say numbers? Let me run this x. Where is x? Let me say numbers dot append x. How will it be different from this? In your opinion?
It should be the same, right? Because you say append, the numbers, they are the first, like append, it adds at the end.
At the end.
It should be like the same.
Yeah, do you think it will be the same? It will not. Do you know a list can contain another list? Do you know that? So here, instead of after 189 we have the content of x, Yusuf, Sani and Asabi. What we have is 554, 189, and then this list as the entire list as an element. Okay, let's run it so that you can see it. So let's run this, and then let's call numbers. Okay? So here, this list, this inner list, is one element in the numbers list. Is that clear? Any question? Please, let's ask questions, because that's why we're here. If anything is hazy, let's ask.
In the first place, you could append, like arrange number as numbers, you add x. Why is this one called like an element inside number?
No, this one is not append, this one is extend. In append, in the append, right? If I say append, if I'm appending this on this, if I'm appending this on this, I'm carrying this and what? and adding to this one, to the last element. Maybe 1, 2, 3, 4, then 5. This can be moved that. But if I'm extending this from this, if this is 5 and this is 3, what happens? It's coming to come here. 1, 2, 3, 4, 5, then 6, 7, 8. Is that okay? This is confusing. Let me create another. Okay. Look at x is equals to 1, 2, 3. Y is equals to 4, 5, 6. Okay? If you say x dot, okay, let me call this 5, 6, 7. If I want to have a list that has 1, 2, 3, 4, 5, 6, 7, what do?
You append.
I append 4 on where? On x. So I have x dot append what? 4. Isn't it? If you do that, what do you have? X will now be 1, 2, 3, 4. And then if I want to now have 1, 2, 3, 4, 5, 6, 7, what do? I do x dot extend. And if I do that, and I call on x, I have what? I have 1, 2, 3, 4, 5, 6, 7. Is that clear? Is that clear? So let's continue. So apart from that, there are several others. For example, if you do the look at index. If you want to get the index of a particular element, insert. If you want to insert something in a particular index, if you want to pop, what does pop do? Pop tells you, it shows the last element and then deletes it. Okay? It shows the last element and deletes it. Remove, you want to remove an element. Reverse, if you want to reverse a list. Sort, if you want to what? If you want to sort. What's the difference between reverse and sort?
What is undo? What's sorting?
Now, if I have x is equals to 2, 4, 6, 3, 1, 5, okay, 7. If you run this, what's x? X is what we have here, isn't it? If you say x dot reverse, okay, do you understand? So if you reverse, from reverse, the front becomes the back now, isn't it? So we start counting from where? 7, 5, 1, 3, 6, 4. We have 7, 5, 1, 3, 6, 4, 2. Is that okay? So let me reverse again so that it becomes the way it is. If you run again, it becomes the normal, isn't it? So now if you say x dot sort, sorting means to what? Lowest to highest, isn't it? So when you call on x, You have what? 1, 2, 3, 4, 5, 6, and 7.
Yes, sir. Did you define them in the beginning?
What?
They are saying that name is not defined.
What's
when
not?
I want to run it.
What's not defined?
X is not defined.
And you have to declare the X first. You have to run it first.
When I click on run, it will display not defined.
Yeah, let me fix that. You click on X first. No, just click no. What is run it. X. Don't click on inside the cell. Dots. Okay. Bracket. 4. Then 1. 4. Then 1 equal. So now type X. 1 doesn't. You see that X is no longer 1, 2, 3 or 1, 2, 3, 4. Now you can also extend X by Y. So you can do X dot extend Y. Okay? Extend Y.
No.
No, yeah, bracket. Y. Run it. So I believe this is all clear now. This is also clear. So and in indexing, you know there is in indexing. Anyway, before you come to indexing, there is this function called range. Range is a function that is used to generate a sequence of numbers as a list. And in most cases, you need to cast it as a list before you see the. So, for example, if you come here and you see, if you see X is equals to list range 10. So you're saying X is a number between 0 and what? 0 and 9, isn't it? If you want the list to end in 10, what do? You put what? You put 11. Do you understand? You put 11. So you have what? So that you can have 0 to 0 to. Do you understand? What if you want to get, let's say, a list of numbers from 1 to 100? You know, if you put 101 here, isn't it? If you put 101, what happens? It will give you 0 to what? It will give you 0 to 100, isn't it? It will give you 0 to what? 0 to what?
Last number.
To the penultimate number, last but 1. So what if I want to start from 50? Let's say 50 to 100. So if you put only one number, you are telling Python that it should start from 0. Okay? But if you put two numbers, you are saying start from the first number and end in the second but 1 number. So if you put 50 here, to start from 50 and end in what? In 100. Is that okay? What if you put 3 numbers? What if you put 3 numbers? I'll tell Daddy that you stayed in Convocation Square and was eating rice. What? Huh? So if you put, let's say 50, 100, let's say 2, what here? So it gives you from 50 to where? To 100, taking a step of what? Of 2. So it is start, stop, step. Okay? SSS. Eh?
I don't understand the two.
Yeah, the 2, it means, if you don't put 2 here, you just put 50, 1.
Yes.
It will start 50, 51, 52, 53.
Okay.
But if you put 2 here, you are saying take 2 steps.
Okay.
So you have 50, it will skip 51 and then 52, skip 53, 54 till it reaches the last number. Yusuf, what if I put 5 here? What do you think will happen?
5, 5.
Hmm?
It will skipping 5.
It is giving 5, 5. Also, we have 50, then what? 55, 60, 65, 70, 75, 80, 85, 90, 95, 101, isn't it? So that's what's happening here. And even in the way we index, okay, we can use that to, okay? Do you understand?
Yes.
So for example, if you say 152, what does that mean?
1 to 5, step 2.
It will start from 1 to 5, taking a step of 2 units. Yeah? For example, if I come here and I say x is equals to 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And I come here and I say x 1 to 4. What will be the answer? Hmm?
Start from 2.
This is 0. No, indexing in Python starts from where?
0.
From where?
1, 2, 3, 4.
Indexing in Python starts from 0. So it will start from where? From 1, go?
Yes, 4.
Isn't it? Where is 4?
1.
This is 0, 1, 2, 3, 4. So it will not do this and it will stop here, go?
Yes.
So it will be, if I run this, it will be what? 468. Even though 4, according to the indexing, is what? 0, 1, 2, 3, 4. This is 4. But it will not do that. It will stop in the what? In the penultimate. Exactly. What if I do like this?
Skip 2.
Hmm? Hmm?
It will start from 4. It will skip.
It will start from 4. No, definitely we know, regardless of what is here, isn't it? It will start from 4 and end in what? End in 8. Now we take the step, starting in 4, end in 8. So it will, if this were 1, it will start from, it will do 1, it will do 4, 6, 8, right? Isn't it? But if this is 2, it will do what? It will skip 6 and only print what?
8.
No, it will keep 4, 6. It will do the first one, that was 4, then skip 2, that was skip 6, and then goes to 8. It's clear now. It's very straightforward.
Yeah, but when it was just 1, 4.
When it was 1 and 4
Yes.
alone, it will be 4, 6, 8.
Yes.
When you have 1, 4, if you don't put anything, it's assuming that you're taking a step of what? Of 1. So you can, if you like, also explicitly state the 1, isn't it? So this and this and this are the same thing. And if you run this, they all give you
Okay. Yes. It's clear.
Give you 4, 6, 8.
Yeah.
But if you say take a step of 2, you say 4, 8, isn't it? If I make this to minus 1, 2, and I put x, to be what? You know minus 1 means what? To the last, isn't it? So, yes. To the last. This minus 1 now. If you do minus 1, okay, you came late, go, this is 20. Eh? Minus 2 is what?
16.
It will be 18. Eh?
Okay. Okay.
It will be 18. So okay. Continuously. So what if I come here and I say, you know, if I say from, if I do like this, what happens? Everything. It should print everything, isn't it? If I do 0, 0 like this,
From 0.
from in the 0 and everything, so this also is same as everything, but what if I say 4, like if I do 4,
From 0, from 4.
it starts from index 4 to the last one. So we have 0, 1, 2, 3, 4. You start from 10 to the last one, cool? So those should be, yes. What if I come here and I do 6? Please, let's get the logic. If you refuse to put a number and you put a column, it's assuming you are starting from the what? If it is the left hand side, from the beginning. And if it is the right hand side, it's assuming that it's what? The last one. Okay. So here, what will happen?
It starts from the beginning.
As index 5. Yes. It usually starts at the penultimate value. Okay? So this is 0, 1, 2, 3, 4, 5, 6. 6, right?
Yes.
And you go 6 here. So it will not stop in 14, it will stop in what?
12.
In 12. Exactly. Exactly. It's clear. So look at this. That's what we have here, 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 and here. Then when you put minus 1 here, it's a step, huh? Do you understand? Just like if you come here and do like this, if you run this, what will happen? It will also print everything, huh? Start from the first one to the last one, taking an index of what? Of 1. If you put 2 here, Uncle, 2, 6, 8 of the what? For the whole list, huh? If you now put minus 1 here, you know minus 1 is a step. So a step of minus 1 simply means in mathematics the reverse code. Yes. So it starts from 20, then 18, 16. So let's continue.
So the difference between this one and the first minus 1 that stops at the last.
Yes. When minus 1 refers to an index, it's referring to the last one.
Last, yes.
But when it's referring to a step, it's referring to the verb.
So the step here now is the double column.
No, the third one. I said start, stop, step. SSS. Okay? This is X. I said 2 column 5 column 2. Okay? Let's see 7. Let's see 3. This is the start. This is the stop. This is the what? The step. Step.
Okay.
Okay. So do you know that you can also call several useful functions on lists? I think we've called one earlier, last len. What does len do? Len. It tells us the number of elements in the list, isn't it? Let me give you one short quiz. What do you think is the? This one I'll ask you. So nobody should attempt. 1, 2, 3. Yusuf. Okay. Lis. Yusuf, if I do len x here, what do you think will be the value?
It's going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. From 0, 10 or 11.
What's the value? What's the answer? Hmm? 11? Hmm? You know,
But actually,
no, just meet him. This one, go. This one.
Yes.
This 2.
Yes.
This is 3.
Yes.
This is 4.
Yes.
This is 5.
Yes.
6, 7, 8, 9, 10, 11.
yeah,
Is that okay?
that one 11.
That's 11, isn't it? That's 11. So it means you can have a list. So what? Look at it. If I want to print out this 20, how can I do that? I want to index 20. If I want to index this f, I will simply come and say x what? 0, 1, 2, 3, 4, 5, 6, 7. Isn't it? If I do x7 here, it returns f for me. Go. Now I want to index out. If I do 9, I will get 3.45. Go. So what if I come here and I want to get this 20? How will I index that?
You write the index of this one.
Yes, you remove it first.
Index.
The index of the inner list.
Yes.
So what's the index of the inner list?
10.
Hmm?
Which is 10.
Minus 1 code 10.
Minus 1 for 10. Very good. Ashede Yusuf Shimade. I thought it's just the LISFN. Yeah, so it's either x10 or what? Or minus 1, isn't it? Huh? So I now want to get the what? The 20. 20 is the what? Is the first go? 1, huh? I can just come and put 1. 1.
21.
Yeah?
Okay.
This is 0,
Yes,
1.
1.
So we have what? 20. It's clear? It's clear now. This is x minus 1. Okay? And then this is x minus 1, and then this is 0, 1. So this is what? This is what? What if I do x minus 1 minus 2? 30, go? Isn't it? That will be 30. isn't it? That will be 30. That will be 30. Let's continue. So you can also do max. Max will simply give you the maximum value, and then min will give you the minimum value, isn't it? Yeah. So we just seen that list can be of different types. Cool. It's not very useful, but possible. You can, just like we've seen in this our example. This list contains heterogeneous elements. We have integers, we have strings, we have floats, we have another list. So you can have boolean, you can have true. Still possible. You can have 10 greater than 5. Okay? 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 Yes. So if I do x 0, 1, 2, 3, 4. If I do x4, what will be the answer?
One, two, three, 4. 10 greater than 5.
If I do x4, that's 0, 1, 2, 3, 4. What will be the answer?
Now, if you index,
If I index x4, that's x0 will be 1, x1 will be 2, x2 will be 3, x3 will be Yusuf, and x4 will be what? This. So if I do x4, if I run this, what will happen?
10 greater than 5.
Pepper.
0, 1, 2.
Huh?
Did you not say the penultimate?
So it is
10 greater than
5.
So what's the answer?
Which is true.
Ajia, what's the answer? No, don't do it too. If I do x3, I get Yusuf. What if I do x4? Should be true. Because this is a boolean, it will not print 10 greater than 5. It will print true. Is that okay? It's clear, no? So lists are mutable. They can be changed. Abi? Do you agree? Lists can be changed.
What can be changed?
They are mutable. They can change. If you have x equals to 1, 2, 3, 4, I can append, I can extend, I can even index and add another value, isn't it? You cannot do that with some other data structures. So, quick quiz. Are lists mutable?
Yes.
So let's look at tuples. So tuples, we will not waste time here. All that you can do on lists, you can also do on tuples. The only thing that you cannot do on tuples is that anything that has to do with mutability is not applicable to tuples. And if you want to declare a tuple, you use the normal bracket. For lists, what do we use? Square bracket. For tuples, we use the normal bracket. And for dictionaries, we use what? We use the curly bracket. Okay? They are all useful. Square bracket for lists, normal bracket for tuples, and then curly bracket for lists. So whatever we have done on lists, we can also do on tuples. The only thing that we cannot do is what? Is change anything that will change the value. For example, look at it. If I come here and I say, if I say x is equals to 1, 2, 3, isn't it? I can come here and say x x1 or x1 is equals to 100, isn't it? And if I run this now, if I call x will be what? 103, isn't it? It means x is mutable. But if this were a tuple, and I attempt to do this to tell you, no, tuples cannot, because what? Tuple does not support item assignment, isn't it? I can come here and append, isn't it? If this were lists, I can come here and see x dot append what? 67, isn't it? And that would be 1, 2, 3, 6, 7. But for tuples, so whatever you do on list, you can also do on tuples. The only thing that you cannot do is anything that you want that will change it. And that's why I look at something now. Let's for the smart eyes. If you do their list, okay, and then come and do their tuple. Okay, but let's hide this one. Append. Can append change a list? So it means if you do the tuple, you should not see it, but you will not see it there. Eh? You will not see it there. Out of clear, it will change it. Copy won't change anything. So we should expect to have copy as a method in what? In tuple. What of count? Counting something does not change anything. So we expect to. What of extend? It will change, isn't it? Insert, it will change. Pop, remove, reverse, sort, they will all change. So that's why if you do that, the only two things that do not change anything is what? Count and index. Copy also is not there. Yeah, so but I think you get the logic, isn't it? Anything that will change the data structure is not applicable in. So should we take questions here so that you can start dictionaries tomorrow? You have 5 minutes. Yes, ask a question.
Why do we use? What's the difference between tuple and list what's the essence that tuple and list are?
Yeah, sometimes you can design a program. We know that fundamentally whatever we do with list, we can do with tuple. We can index, you can check the length. So if you're writing a program and you do not want for any reason, if you have a list of numbers or a list of anything to be changed, if you make it a list, what happens? It can be changed. And if you make it a tuple, even if somebody attempts to change it. So for security, if you're designing a program that you have a list of numbers and you do not want for any reason anybody to come and change it, then you can just use tuples instead.
If you want it as a 4-digit number and it must be 4-digit.
Yeah, you want it to be a list of these are the members of this class, isn't it? These are the class members, isn't it? Mr. A, Mr. B, and Mr. what? Mr. C. If somebody knows that names is the variable that keeps the staff members, somebody can come and say what? Names dot what? Dot append D, isn't it? Yeah? And then if you come and print names, you see that what? It's A, B, C, D. Is that okay? But if you make this a tuple, so even if somebody, you can even freely tell them the variable. Somebody wants to add another person, it will tell him that, man, you cannot add anything. It's clear. So if we come tomorrow, God's willing, we will continue from dictionaries. Any other question? Yes.
I have something to ask. When we were using this anaconda, one of the advantages that you said was when you open a bracket, it closes.
Yeah. Someone asked this whether. So you go to settings. It's previous anaconda versions.
Okay.
It comes with that functionality ticked, but in the recent versions, it allows you to explicitly. So you come to these settings. I see it. Look at the board. If you open your digital node, go to settings, and then you click on this auto close bracket.
Yes.
Huh?
Yes, yes. I know. Yes.
Yeah, no?
No, because
There. Same one. Same one. So it should be inside. Okay.
So the Python allows the tabulation of numbers.
Sorry?
Python, do you allow tabulation of numbers, tabulate
Numbers.
Like,
Of course.
in tabular form.
Yes. If the number is in tabular form, you can. That's where we're doing data analysis now. We're going to come to that. Yeah, treating numbers that are in tabular form. Yeah. So the numbers are already in tabular form, maybe in Excel or CLS or CSV, and then you import them and then you manipulate them and then you save them in tabular form. Yeah, of course. Yes. Okay. I think it is it.
Okay, sure.
Yeah. Okay. Oh, for those online. Class has ended, bro.
Just going to